Hi, welcome to the Introduction to Data Science by Webshala. Today we are going to learn about what is data science, how we do things in data science, and a brief introduction what is data science actually. So nowadays we must have been hearing about data science a lot, and we are also seeing that data science engineers and people who have knowledge of data science are in high demand and they are being paid really high. Why is that so? Because there is the need of these kind of peoples and there is very scarcity, so demand and supply kind of thing is very low. Demand is high, supply is low, so that's why people are in demand. And data science in simple terms is what we take the data, apply some mathematical statistical models on that, and we take out relevant information from the data, and then we present it or we use that information to do whatever we need. So what is data science actually? So it starts with like a question: how we can increase our sales? What can we do so that I can be on the top? What can we do to improve our product? What are the customers' feedback? What is the flaw in my system? What is the flaw in my product? Why my sales is going down? So these kind of questions, they require data, because without studying the data we cannot answer why our sales down. How can we increase the sales? We need to identify the features liked by the customer so that we can implement them in our cars and we can go on. So this is how it starts with a one simple question, and then we acquire the data relevant to that field, and once we have that we will go for data cleaning. After the data acquisition, the data most of the time is not completely filled, or you can say perfect. So we need to fill the null values, empty values, or the wrongly filled values. We have to correct them all. So that process is called data cleaning, and the data preparation or transformation is the part where we have some part of the data, some column of the data which is represented in form of categories. Like if we have a data for different manufacturers of cars, so each car manufacturer will have different cars, and each car will belong to some certain category. So one would be SUV, MUV, sedan, or these kind of things. So once we have that kind of thing in our data, we need to convert those into numbers. That categorical column has to be converted into numbers, which can be done easily. We will see that in due course of time, how to convert categories into numbers. Then we do some exploratory data analysis by plotting histograms, bar chart, pie chart, and all different kind of graphs based on our requirement, because this helps us in understanding what statistical model will perform best on this. So hence, once we do exploratory data analysis, we have an idea that what my data modeling is, what my data model would give me the best value with minimum amount of time. We implement that data model and we take out the result, and we put that result into a visualization or more simpler form so that everyone can understand and management can take decision based on those recommendation came from our data analysis. So what is data science at core? It is mixture of three fields. One is business knowledge, one is mathematical and statistical knowledge, and other is computer science. So person who has all these knowledge of all these fields is called a data science engineer or a data scientist, because he will take the data. First he will identify the requirement, identify the problem statement, what my problem is. Then he will take the data with the help of computer science from the relevant fields, website, or any other place, and after collecting the data he will modify the data in the required form. He will prepare the data, clean the data, and then he will do EDA, which as we discussed in the last slide, and then he will come on to the mathematics and statistics part of it and take out result from that data, take out relevant information from that data. Once we have that relevant information, we can go ahead and do our predictions and preventive measures. So applications of data science: first, autonomous car. We see it a lot. So why this thing is happening? Because there are n number of scenarios for a single there are n number of solutions to a single scenario. So how it is being happening is, like, once we are driving, suppose I give a car to 4 people, same scenario, same car, but 4 different people. The scenario, like, suppose scenario would be you are driving a car on a straight road and somebody accidentally comes in front of your car. So 4 people will have 4 different solutions. One might put brake immediately, one other might put brakes slowly, but the third person might change the lane, or there can be a number of scenarios. So computer cannot do these kind of things on its own. It will get confused what to do. So we take the data from this data from 1000, 2000 customers or n number of customers, and then we derive a result that, okay, all those people wanted to have one thing in common, that we do not want to hit the target, and what would be the best possible course of action in our scenario. Based on n number of scenarios, I can learn, like we learn. So we learn by doing, so computer will also learn by doing. So that's what the importance of data science is, because once we have the data, we can take relevant information out of it. Next part, the real and like I would say the application of data science, which every one of you might have seen. All of us at some point of time might have received a call regarding, sir, you have been selected for loan or credit card or any other kind of loan or anything. So this kind of thing, why do they select it? Why do they call you have been selected? Because what bank does is, in the background, that the bank will give the details, all your financial detail, your age, your current location, like city or district kind of a location, course location to the bank, and how many loans you are having, and how many EMIs you are having, or and what time your EMI is going to get over. So the person who is already having an EMI on his head, and his EMIs is going to get over, so bank will try to focus that target, because he is already prone to EMI. He is already already under the system of EMI, so he will not bother having another EMI on his head. So this is all these features contribute. So like there are 2 person, one is middle class person living in city, and another person is super rich living in some rural areas. So the super rich person will not get calls for loan and EMIs or credit cards, because he is living in rural areas. That affects everything, most of the things. So each and every feature has a weightage or a contribution part into it. So that we need to calculate what is the importance of what is the importance of location, what is the importance of age, what is the importance of monthly expenditure, what is the importance of salary he is earning. So all these features contribute. So in data science, we have the data, we need to decide that based for all these 10,000, 100,000 or 100,000 customers, what is a common what kind of a common result I can derive from this, so that I can apply it on these 100,000 people and take out the relevant people, and or you can say the probability that there are 80% probability for 30,000 customers to take credit card or loan from us. So we are going to call those kind of customers. So that's the process which is going behind the scenes. So the application of data science, one, you would have seen that once you are searching for some product or anything on your desktop or on your mobile, and after some time you open your Facebook, you want to see the same advertisement, same product or relevant product advertisement on your Facebook, Instagram or any other page, because company has the record that you have watched this product for the last 1 month, in last 1 month for total 2 hours, 3 hours. For the last 1 week you have been visiting this page for 20 or 30 times, and a total hour spent is total time spent on this page is relatively high, so you are prone to buying. So why not show you those kinds of ad so that you end up buying that thing? So that's what the role of data science is. It tells it's automated nowadays, but that all this is data science, generating the probability that this person is having high probability of buying this thing in very near future. So why not give him this kind of ad so he buys it from our site or from as soon as possible. So other applications of data science are in e-commerce to predict, like most of you might have seen this thing done by Zomato. That's very nice, I would say. Suppose you order lunch one day, so you keep an observation that after 3-4 days at the same time, whether you order, when you ordered the last thing for lunch, last lunch from Zomato, they'll say, hey, it's lunchtime, order something from Zomato, tasty from Zomato. They'll do it because that's all data science, the keeping the data and forming a decision. Oh, this person had ordered something from our site at like 2-3 days back, so why not give him one more so that he buys from us. In manufacturing, like predicting potential problems, predicting potential failures, predicting failure conditions, like, oh, the plant condition, this kind of plant condition was last time 2 days before the breakdown, so why don't ring an alarm so that plant breakdown is imminent in 2 days because of these reasons. So these kind of thing, these applications of data science are being used in manufacturing. In banking, you already know how fraud detection, credit card risk modeling, and customer lifetime value, for how long this customer will be with us. In healthcare, like in COVID, the data scientists developed a model where they were predicting on the basis after reading the X-rays images and predicting whether this person has COVID or not with probabilities. So that kind of thing, predicting genes, predicting a child's disease based on the genes or data collected from him. Transport, we already know, self-driving cars and all. In finance, stock market price, stock price prediction, risk analysis. What is the risk in this share or that share or whatever we are having. So these kind of things we can do with data science, and it's being used all over. So now we come to the artificial intelligence versus machine learning and deep learning. So AI is the broadest term, whereas machine learning is a narrower term, and neural network is again sub part of machine learning, and deep learning is again sub part of neural networks. So artificial intelligence is having an information, processing that information and acting on that information. Machine learning is having an information, processing that information and deriving a result out of it, but do not acting. Neural network is like something mimicking our brain. So this is the hot topic nowadays. Everything is running on neural networks and artificial intelligence. And deep learning is when like 2 or 3 neural network combines, then that becomes deep learning. More than 2 neural network combined, so that becomes a neural deep learning model. So artificial intelligence gives us computer ability to act, to see a video and act, to tell whether this person is wearing a mask or not. Okay, if this person is not wearing a mask, computer will not open the door. Autonomous vehicle, intelligent robots, natural language processing. Nowadays you might have heard the trend, Twitter trend. How do we calculate trend? Because we are processing natural language. We are measuring natural language in mathematics. That's what at the core of NLP is. And then implementing, saying, okay, my trend is going positive or negative based on my model, based on my learnings. So this is what NLP, or you can say artificial intelligence is. Artificial intelligence would be like acting on information provided by the machine learning. So life cycle of a machine learning model. What do we do? How do we do a machine learning model? So we gather the data, then we prepare the data. We already discussed this. Then wrangle the data or put the data from one form to the other, which we require or based on our needs. Then we analyze the data. what our data is saying, which model should we use on our data so that we can get the best results in minimum amount of time. Then we will train our model so that we learn from the data. That is called training. Once we have done the training, we always keep some part of the data available to us which is not given to our machine learning model, because we want to test how it is performing. So we will give the test data to computers, for which we already have like something kind, we already have the questions and the answers. We are going to give it to the students and see how much they have learned from the class. So that kind of thing we will be doing. We will be keeping some of the data with ourselves, and we will not be showing that data to computer, and we will ask him to learn from the remaining data, which generally is 80-20, 80% training data, 20% test data. Once we have done that, once we are satisfied that okay, my model is performing good on train as well as test data, my accuracy is up to a certain number depending on the requirement, we have our model has been passed, we just deploy the model so that everyone can use it now. So in machine learning there are three types of major classes: unsupervised learning, supervised learning, and reinforcement learning. So first is supervised learning. Supervised learning is where we know our target, what we need to do, what we need to predict, what we need to take out from the data. So again, supervised learning is of two types: regression and classification. Regression is finding a mathematical relation between my on my data. Suppose predicting a house price based on its feature, predicting weather, predicting market forecast. These kind of problems are called regression problems, where our data or the target variable which we need to find is a numerical and continuous data. So the next part of supervised learning is classification. Suppose we need to classify cars, so we can classify cars based on their body type, like sedan, MUV, SUV, hatchback. So these are all, this is an example of classification. We are classifying the car based on their body style. If we are classifying the image, whether this image is fit for a child, not fit for the child, this is classified. We are putting a tag, a class tag on that image or video or whatever. Then we come to the second type of machine learning called unsupervised learning. Unsupervised learning is where we do not know our target variable. We do not know what is target variable. Only thing is we have the data, we need to take out something from it. So there are two parts of it: unsupervised learning, clustering, and dimensionality reduction. Clustering is to form the cluster systems, or you can say a recommender system is an example of clustering, where similar kind of movies are put into a single cluster and then we move on. Okay, so this is kind of clustering, identify features or identify an instance based on its similarity to others. So that is clustering. Then dimensionality reduction, to reduce that. Suppose we have a huge data, so not all data is useful. So we don't know which data is useful, which data is not. So that part comes under dimensionality reduction, since we would be dropping or removing some unuseful data from our model. That is dimensionality reduction. Third is new form of machine learning, that is called reinforcement learning. Feeding the model the feedback of its predictions, like you have made this prediction wrong, you have made this prediction right. So once we start doing this, that model learns more. Okay, this prediction was wrong the last time, so there might be some changes in my parameter. So model will keep on learning and become more efficient. So game AI is that example of machine learning, reinforcement learning. So once you do one thing, computer learns, okay, you are doing this thing in this way, I will counter that. So some of the examples of machine learning are self-driving car, your recommendation engine, the recommendation engine built by Netflix, which is very, very efficient and very good. And photo search, is there any person there in the photo? Is there a particular object in the photo? If yes, okay, tag that object, that kind of thing. So nowadays you might be using for Facebook filters. In earlier days those filters would have been going haywire, but now as the time as users kept generating more data and more data, that helped Facebook to mature its algorithm. Now they are so mature that you do not have those features showing absurd behavior. Now they work perfectly as they should, because now the machine has learned very well. A spam filter is also an example of machine learning, to learn from our inbox what kind of spam email and genuine email you receive. So that's the example of machine learning. So now we come to the data scientist career options. So there are 8 to 9 different career options related to data science, and all of them are very good. So as we can see, general average salary of a data scientist in US is $120,000 a year, roughly $12,000 a month. So which is roughly very high salary. Generally average salary in US is $4,000 to $5,000 a month. Okay. So as according to the Harvard, data science is the sexiest job of 21st century right now. So the skills required for like data science are statistics, linear algebra, and some part of calculus. Machine learning you should know. Software engineering, a little bit software engineering you should know. How to visualize the data, how to put data from one form to another. That's all we need, and one programming language to do all these kind of things. So this is all about basic things about data scientist. So as we can see here on like our open analytics jobs in India in 2018 were more than thousands, or you can say more than 10 lakh jobs were open for data analytics in India. This is 2018 data. This data tells us city wise. So Bangalore and Delhi are the top cities having major share of data analytics jobs. And as you can see that machine learning and data science engineer are required in each and every industry. Travel and hospitality is also hiring, telecom is also hiring, automotive is also hiring, retail and CPG is also hiring, modern day entertainment, e-commerce, and the highest is banking and financial services. These would be taking the maximum amount of data scientists and data engineers, because they have the maximum demand and need. So tools and techniques what you will be learning in our program would be Python, basic SQL, machine learning, deep learning, TensorFlow. These are some of the libraries. NumPy and Pandas are also the libraries which we would be using in our course to give you a complete exposure. And keep in mind, we have developed this course keeping individuals and professional in mind, so that we can get them job ready for data science and machine learning. So AI is profitable. Yes, the impact of AI on different industries profit, you can see that education industry has gained it from the most. Accommodation and food services, your Zomato, Swiggy have gained so much. Construction, wholesale, retail, each and every industry is having this kind of very good impact of AI on its field. So as you can see, the demand, or you can say analytics job profile wise, we can see most of the jobs are in data analytics, and then we have business analytics, big data developer, and so on. So Python is the most common language in data science industry. 61% of the people are using Python. Then we have R only standing at 29%. SAS and SPSS are very negligible. So this would be our some kind of a lecture schedule for our course. Thank you guys.